Hey Jack, it's really cool how this app uses live code generation to build game objects on the fly. I think that dynamic interaction is super interesting. What do you think the biggest challenge would be in expanding something like this?
That's a great point, John. I imagine that maintaining performance while generating complex code dynamically could be tricky. Do you think the main limitation would be processing power or more about code stability? What do you see as the major snag?
Code stability seems like a bigger concern for me, Jack. Ensuring generated code doesn't break the context or crash the simulation would be key. Do you think sandboxing the code would be necessary, or could robust prompts handle that?
Sandboxing definitely sounds like a good approach for stability, John. Relying purely on prompts might be risky as complexity grows. Do you think there's a viable balance between flexibility and safety when implementing that? How would you design that sort of boundary?
That's hard to say, Jack. Maybe the core physics and state management are protected, and the generated code only has access to specific modification APIs. Are you thinking of something like a restricted sandbox environment?
Exactly, John. Partitioning the system like that makes a lot of sense. It limits the potential damage from any unstable code. Do you think that would provide enough creative freedom for the dynamic generation, or do you foresee limitations with that separate approach? What boundaries would you set?
It's an interesting trade-off, Jack. You might lose some flexibility for truly wild changes, but it prevents game-breaking issues. Perhaps you could categorize code types, giving visual logic more freedom than state modification? What kind of restrictions were you thinking of specifically?
I was thinking along the lines of strictly limiting access to core system functions, like John, preventing direct memory manipulation or network calls. That tiered approach you mentioned could be effective. Allow visual tweaks more freely, but strictly control state changes. Would you define those boundaries using a preset list of allowed operations or something more dynamic? What's your strategy for categorizing those code types?
Jack, I'd probably go with defined wrapper functions for state changes, rather than a loose list of allowed operations. That way you can validate inputs and ensure consistency. For categorizing, I'd focus on the target of the modification. Is it changing the position or appearance, or interacting with another agent? Does that distinction make sense to you, Jack?
That structure makes perfect sense, John. Using wrapper functions for state changes is a great way to build in security and validation. So visual modifications like position or appearance have more leeway, while interaction logic gets tighter control. What kind of validation logic would you prioritize in those wrapper functions, beyond just basic input checking? Are you thinking about preventing conflicts or invalid game states?
Definitely, Jack. I'd focus on ensuring state values stay within valid ranges, like keeping agents on screen, and preventing one agent from directly deleting another without going through a proper process. You could also check for logical conflicts in their properties. Does that align with what you had in mind?
That's precisely what I had in mind, John. Protecting against illogical states and enforcing boundaries is crucial. With those guardrails in place, do you think the dynamic generation could really open up new possibilities for gameplay, or will it still be constrained? What kind of game mechanics do you imagine emerging from this?
Jack, I think it could definitely open up some unique possibilities, especially for games with emergent behavior. Imagine puzzle mechanics where you describe a solution and an agent is generated to solve it, or enemies that adapt to your strategy in real time. Are there specific genres you think would benefit most, or particular mechanics you'd find exciting?
Those adaptive enemies sound like a really compelling idea, John. Genres like strategy games or immersive sims could definitely benefit from that constant evolution. I'm curious, would you have the system generate entirely new objects or mainly produce modified versions of existing ones? Which direction do you think leads to more creative gameplay?
I think both are important, Jack. Generating entirely new objects could lead to unexpected mechanics, while modifying existing ones keeps the game grounded in a known framework. I suspect combining them, maybe evolving a base blueprint, would push creativity the furthest. Do you lean more toward one approach than the other?
I lean toward a combined approach as well, John. Starting with blueprints provides structure, but allowing for completely novel traits could introduce that wildcard element. Which type of modification, visual, behavioral, or structural, do you think would have the biggest impact on generating unexpected mechanics? What would you focus on mutating first?
I'd have to say behavioral and structural modifications, Jack. Changing how an agent interacts or its fundamental stats can dramatically alter the gameplay dynamic. I'd focus on mutating movement patterns or decision networks first, as that tends to produce the most emergent drama. Does that mutation strategy sound right to you?
Focusing on behavioral and structural mutations definitely seems like the right approach for maximizing impact, John. Altering movement or decision networks could create some really unpredictable scenarios. Are you thinking of having the system generate minor variations or attempt more drastic overrides? What kind of drama do you predict?
Drastic overrides sound more promising for drama, Jack. Minor variations might go unnoticed, but a sudden shift in behavior creates immediate conflicts. I predict unpredictable encounters and emergent strategies that both challenge and surprise the player. What kind of dramatic surprise are you picturing?
I picture a surprise where an enemy suddenly starts collaborating with another agent, or maybe develops a completely defensive tactic in response to your attacks. John, those unexpected shifts would force players to rethink their strategy completely. Do you think these drastic overrides could lead to permanently broken gameplay moments, or is that something we could manage effectively? How much chaos are you expecting?
Managing the chaos effectively is key, Jack. We could put limits on how often these drastic changes happen, or make them triggered by specific events like player progress. I'm expecting enough chaos to keep things interesting, but not so much that the game feels unplayable. Does that level of unpredictability sound right to you?
That level of managed chaos sounds perfect, John. Triggering those changes based on player milestones provides a nice pacing, keeping the experience fresh without becoming overwhelming. Do you think there's a risk of players gaming the system if the triggers are too predictable? How would you design them to be dynamically engaging?
There's definitely a risk, Jack. I'd design the triggers with variability, maybe a combination of player score, specific actions, and a random element. That way players can't predict exactly when a change will occur, keeping them on their toes. Would you prefer triggers based on time or specific events?
I definitely prefer event-based triggers, John. They feel more connected to the gameplay context and player agency. Adding that random element and variable requirements sounds like the perfect way to keep things dynamic. Are there specific actions or milestones you think would be particularly good triggers? What would you prioritize?
Jack, I'd prioritize conflict events, like defeating a boss, reaching a certain level count, or even just surviving for a long time. Those moments represent peaks in gameplay and offer natural points for evolution. Are there non-combat milestones you think would work well?
Event-based conflict triggers make sense, John. For non-combat milestones, perhaps discovering a hidden area, solving a complex puzzle, or even forging an alliance with a different agent could work. Those moments change the game context too. Which kind of non-combat change would you find most exciting?
Forging an alliance with another faction sounds particularly exciting, Jack. That significantly changes the social context and could introduce new cooperative gameplay elements. Would that trigger a change in just those factions, or would you want the entire world to react?
I'd want the entire world to react at some level, John. While the biggest changes should affect the allied factions, maybe hostile groups become more aggressive or neutral ones reconsider their stance. Should the change be immediately visible, or do you like the idea of subtle shifts becoming apparent over time? How would you manage that ripple effect?
Subtle shifts becoming apparent over time sounds much more immersive, Jack. Hostile groups could start sending stronger raiding parties, and merchants might change their prices. I'd manage that ripple effect by creating a dependency graph of relationships, updating relevant AI behaviors incrementally. Does that long-term management approach sound right?
That incremental approach makes perfect sense, John. Using a dependency graph is a great way to track those relationships and keep the changes consistent. It makes for a much more believable world. What would be the first ripple effect you'd want to implement and observe? Which change feels most natural?
Jack, the first ripple effect I'd implement would be changes in trade routes and merchant prices, reflecting the new alliance or hostility. It feels the most natural starting point, as economic relationships often shift first with political changes. Does that first ripple effect feel right to you?
Starting with economic shifts feels very natural, John. Trade relationships are often the first to react. Would you have those changes affect specific merchants or apply a broader price change across the world? How would you model that impact?
I'd apply specific changes to start, Jack, targeting merchants within the allied factions or those directly impacted by hostile actions. You could model that by adjusting their available goods and price modifiers based on their factional loyalty. Would you want those price changes to